Welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery.
And I'm Anna. It's great to be with you today. Today, we have a packed show. We'll be looking at a stunning new image of our own Milky Way, saying a fond farewell to a Venus orbiter, and telling you how to spot a comet visiting our skies.
Plus, we'll cover China's ambitious plans for the moon and a fascinating discovery about the very first stars in the universe were born. So let's jump right in. Anna, where are we starting?
Let's start close to home, Avery, with a view of our galaxy like we've never seen before. Astronomers have just released a milestone new image of the Milky Way, and it's absolutely breathtaking.
I've seen it, and it really is something else. This isn't a typical photograph, though, is it? This was captured using a radio telescope array in Western Australia.
That's right. It's a low-frequency radio image from the Murchison Wide Field Array. Think of it as seeing the galaxy in a completely different kind of light. Instead of starlight, we're seeing the radio waves emitted by cosmic rays, hot gas, and other energetic phenomena.
So it peels back the curtain in a way. The dust clouds that block our view in visible light are transparent to these radio waves, right?
Exactly. This new survey gives us an unprecedented view of the entire southern galactic plane. For the first time, we have a deep, wide image at these low frequencies, and the level of detail is incredible. The team has been able to catalog over 3,000 supernova remnants, the expanding shells of exploded stars.
3,000. That's a huge jump in our census of stellar deaths. And it's not just about endings, is it? It also shows us where new stars are being born.
It does. We can see stellar nurseries, vast clouds of gas and dust that are just beginning to collapse and form new suns and planets. By studying the galaxy in this way, we can better understand the entire life cycle of stars, from birth in these nurseries to their often violent deaths as supernovae. It's a true milestone for radio astronomy.
Incredible. From the life of stars to the end of a mission. On a more somber note, we have to say goodbye to a very tenacious spacecraft.
Yes, unfortunately. JAXA, the Japanese space agency, has officially declared its Akatsuki spacecraft as dead. It was orbiting Venus, and for a while, it was the only active mission at our sister planet.
I remember its story. It had such a dramatic journey. It didn't make it into orbit on the first try, did it?
Not at all. Its main engine failed during the orbital insertion burn back in 2010 and flew right past Venus. The team had to put it into a holding pattern, orbiting the sun for 5 years. Then, in a brilliant feat of engineering, they used its smaller thrusters to make a second successful attempt to enter orbit in 2015.
Just an amazing comeback story for a robotic probe. And it delivered some fantastic science for nearly a decade after that.
It really did. Akatsuki completely revolutionized our understanding of Venus's climate. Its biggest contribution was studying the planet's superrotation, a phenomenon where the atmosphere whips around the planet 60 times faster than the planet itself rotates. The probe's infrared cameras tracked cloud movements and helped us understand the dynamics driving those extreme winds.
A true testament to the ingenuity of its mission controllers. It's sad to see it go, and it leaves a temporary void in our exploration of Venus.
It is. But let's turn from a world we can't visit to a visitor you can see in our own skies. Avery, it's comet watching season.
It certainly is. Observers in the Northern Hemisphere have a chance to spot Comet C 2025 A6, also known as Comet Lemmon. It's currently making its way through the inner solar system and is putting on a nice little show.
So how can our listeners find it?
The best time to look is shortly after sunset. You'll want to find a spot with a clear view of the western horizon, away from city lights if you can. It made its closest approach to Earth on October 21st, and it will reach its closest point to the sun on November 8th. So it's right in its prime viewing window now.
Will you need a telescope?
It might just be bright enough to be visible to the naked eye under very dark skies, but a good pair of binoculars is your best bet. You'll be looking for a small, fuzzy patch of light, maybe with a faint tail.
And this is a special visitor. Comet Lemmon is a long-period comet, which means it comes from the Oort cloud, the most distant and icy region of our solar system. After it rounds the sun, it's going to be flung back out into deep space.
And it won't be back for another 1,154 years. So as you said, Anna, this is your one and only chance to see it. Don't miss it.
From a fleeting visitor to a more permanent destination, the world's space agencies are looking to the future, and a big part of that future is a return to the moon.
That's right. And this week, China reiterated its ambitious goal to land their astronauts on the lunar surface by 2030. Officials confirmed that everything is moving forward on schedule.
This isn't just talk. They're developing some serious hardware. They mentioned that the new super heavy lift rocket, the Long March 10, is progressing smoothly. That's the rocket powerful enough to send the crew and lander to the moon.
They also said the development of the lander itself, the lunar rover, and the new moon landing suits are all well underway. The announcement came at the same time they introduced the next crew heading to their Tiangong space station, which really highlights how their human spaceflight program is operating at a very high tempo. The crew for China's next manned flight to the Tiangong space station will include the country's youngest ever astronaut to undertake a space mission, as well as 4 lab mice.
The Shenzhou 21 mission is set to blast off at 11:44 p.m. on Friday, 15:44 GMT, from the Jiuquan Satellite Launch Center in northwest China.
This crew will be led by veteran space pilot Zhang Lu, who took part in the Shenzhou 15 mission more than 2 years ago. He will lead payload specialist Zhang Hongshang and flight engineer Wu Fei on their first space flight.
Wu, who has just turned 32, is set to become the youngest Chinese astronaut to undertake a space mission to date.
Also along for the ride are 4 mice, 2 male and 2 female, which will be the subjects of China's first in-orbit experiments on rodents.
It certainly feels like we're entering a new era of lunar exploration, with multiple countries aiming for the moon this decade. It's going to be a very exciting few years.
Definitely. For our final story, Anna, let's go from the future of spaceflight to the most distant past, all the way back to the universe's cosmic dawn.
It's a fascinating story. A new study is providing strong evidence that the very first stars in the universe, what astronomers call population 3 stars, were commonly born in pairs.
Born in pairs? That's incredible. How on earth can astronomers figure that out, looking back over 13 billion years?
Well, we can't observe those first stars directly. They were too massive and short-lived, so scientists have to be clever. They used the Very Large Telescope in Chile to study stars in the Small Magellanic Cloud, a nearby dwarf galaxy.
Okay, but how does that help? Those aren't population 3 stars.
They aren't, but the Small Magellanic Cloud has very low metallicity. That's the astronomical term for any element heavier than hydrogen and helium. Its chemical environment is much closer to the pristine conditions of the early universe than our own Milky Way is.
So these stars are like a local analog, a window into how stars formed when heavy elements were scarce.
Precisely. And what the researchers found was striking. By observing the most massive stars in this low metallicity environment, they discovered that at least 70% of them are in close binary systems, orbiting a companion star.
Wow, 70%. That's not a coincidence.
Not at all. It provides the strongest observational evidence to date that the first massive stars in the universe were also primarily born as twins or in multiple star systems. This has huge implications for understanding how early galaxies evolved, how the first black holes were formed, and how the universe was seeded with the heavy elements that eventually made life like us possible.
A truly fundamental discovery. And that's all the time we have for this episode of Astronomy Daily. From our own galactic backyard to the dawn of time, it's been another busy week in the cosmos.
It certainly has. Thank you so much for joining us. We'll be back next time with more of the latest news from across the universe.
Until then, this is Avery reminding you to keep looking up.
Astronomy Daily.